Continue where we left off yesterday. Okay. From our warm-up problem, what form was this matrix in that I gave you? Is it reduced? Okay, it's just row echelon form, right? If it's reduced row echelon form, these would all be zeros up here. Do you agree? Okay, so I gave you a matrix in row echelon form, and it took us about 2 algebraic steps to figure out what x, y, and z were. Do you agree? Okay, so what we're going to do today, I am going to give you a system of equations, and you get to decide what elementary row operations would be best in order to get a matrix into row echelon form. Once you get a matrix into row echelon form, we can very quickly determine x, y, z, w, whatever our variables would be. Okay. So, what I'd like you to do is write down this matrix right here. So our whole goal is to get it to look something like what you had on the board for your problem of the day. You want that seatbelt of ones, or the diagonal of ones, and like a triangle of zeros below it. That's kind of how I like to describe it. Okay? So basically, you need the first row to start with a 1. You need the second row to start with 0, 1. And you need the third row to start with 0, 0, 1. Once you get it to that form, then we can rely on our algebra. Okay? Now, let's recall from yesterday, what are we allowed to do? We are allowed to switch rows. We are allowed to multiply a row by a constant. And we are allowed to add a multiple of a row to another row. Okay? And that's what you practiced in your homework last night. Okay? So go ahead and just take a look. We need to get this into row echelon form. Okay, how about you just turn to your neighbor and talk about some ideas. Wait, I'll draw an arrow and write it on here. Okay, so who would like to share an idea? Chris.
Add row 2 to row, add row 3 to row 2.
To become our new row 2. Okay, so Chris's idea is to take row 2, add row 3, and that is going to replace the row 2. So if we take row 3 and add it to row 2, we would get 0. Oh, that's nice, right? 1, 3, 5. Why was that his suggestion? We get 0, 1 in the second row. That's awesome. That's awesome. Okay? Do you agree with my math there? 0, 1, 3, 5? Okay? Basically, we have that second row taken care of. Okay? Now, we need our first row to start with what? 1. It doesn't. But what does start with 1? Row 3 starts with 1. So, some of you are like, ooh, can we subtract? Ooh, can we divide by 2? I wouldn't divide by 2 unless you absolutely have to, because it's going to create some fractions, okay? And fractions aren't bad, but I would save that as like a last resort, okay? Sometimes you're going to get to the end and have to divide by a number, and that's fine, but I would avoid having to do it in the middle of your problem, okay? So we can take row 1 and switch it with row 3. Get 1, negative 2, 3, 9. 1, 3, 17. Okay, and do you notice how I am notating my work? I'm going to draw arrows so I can follow which matrix comes next, and I'm notating what my row operation is. Okay, so we have our first row taken care of, and now our second row taken care of. This third row needs to be 0, 0, 1. Okay, so it's going to be in your best interest to start with the most left 0 first, then move to the right to find the next 0. So let's focus on this 0 right here. Raise your hand if you have an idea on how to get this to be a 0. Nick.
Take row 1, multiply it by 2, subtract it.
Okay. So I'm going to take yours and I'm just going to address it a little bit. Okay, he said multiply by row 2 and then subtract. I'm going to go ahead and say multiply row 1 by negative 2 to add to row 3, which is exactly what you said. All right. I just like to stick with the addition because that's what we talked about yesterday is the addition of rows. Okay. So row 1 and 2 are going to stay as is. Okay. Now if we multiply row 1 by negative 2, our first entry would be negative 2, and when we add it to the 2, we get 0. That was the goal of Nick's idea. Okay. If we multiply by negative 2, on the second entry, we would get a positive 4, plus negative 5 would be negative 1. Okay. Negative 2 times 3 is negative 6, plus 5 is negative 1. And then negative 2 times 9 is negative 18, plus the 17 would be negative 1. Okay. So I want you to notice how we're doing some calculations in our head. Okay. We've come to a point in our math career that's okay. We can do some calculations in our head, but I do need you to notate what is happening. Okay. All right, so our third row, we know this needs to be 0, 0, 1. Turn to your neighbor and tell them an idea. Lindsay A., what did you tell your neighbor?
We said that you could do row 2 plus row 3 becomes the new row 3.
Row 2 plus row 3 becomes the new row 3. How do you feel about that? Okay, they're already opposites, right? So when you add them together, it's going to create that 0. So row 1 is still 1, negative 2, 3, 9. Row 2 is still 0, 1, 3, 5. And then row 3 becomes 0, 0, 2, 4. Okay. Now here's where I say try not to divide unless you have to, right? We need this to be 0, 0, 1. And so we're going to cut row 3 in half. We have made it to row echelon form. Now, some of you might argue with me saying, well, Mrs. Holman, right here, I know that Z is 2. I know, so write it in row echelon form so I can see that, okay? Since we're using matrices, if you choose to solve a system using an augmented matrix by hand, my expectation is that you minimum get it to row echelon form, okay? I need all of those to be 1s, okay? One step to get the Z is 2 in your augmented matrix. I need to see that. Okay. All right, so now we can solve our system, right? Okay, now we have our augmented matrix that's in row echelon form. Okay, and this is something that you practiced yesterday. This last row means Z equals 2. Okay, going from the bottom up. Right, Eli? Was it really?
Yeah.
Well, look at that. I did not intend for that to happen, but this was our warm-up, wasn't it? Thank you for pointing that out. So we know that Z is 2. Y is -1. And X is 1. You already did the work for it. Okay, now let's talk about this process here. Okay, we're still kind of doing the same things we did with 3 variable systems as far as elimination, right? We had some elimination in there. Multiply row 2 by row 1 by -2 minus row 3. Okay, simply elimination. Okay, but we don't have to worry about the X's and Y's and Z's. We don't have to worry about the substitution until the very end. By keeping it in the matrix, all we have to worry about is numbers. Yes? What? So then you wouldn't understand the other one, right? We got to understand the algebra so we know why this works right here, okay? But right now, this very minute, how many of you like this way better than how we did it in chapter 7? Okay, you don't have to, but some of you are going to. All right, let's do a 2 variable system. Oh, was it? We'll write it down. Okay, so you all can solve this using algebra, okay? That's not what we're going to do. We're going to solve it using an augmented matrix. Okay. Now, if you're in a 2 variable system, taking a row and dividing it by a number or multiplying by a fraction really isn't as scary, right? If we want to get this into row echelon form, we need this first row to start with a 1 and the second row to start with 0, 1. Ideas. Nick. Row 2, row 1, make it row 1. Subtract the 2 rows. Is that what you're saying? Okay. Caleb, did you have something? What do you mean other way?
Like, subtract it the other way, make it go 2.
Okay.
Zero on the bottom.
Okay, we want the 0 on the bottom, right? So you're saying, okay, let's take row 1 minus row 2, and that's going to become our new row 2. Okay. So we would have 0, 3, 9. Negative. Okay. Well, I did mine row 1 minus row 2. If you're doing row 2 minus row 1, then you would have negative 3 and negative 9. You see what I'm saying? Okay. Now, what would we need to do? We need to take row 2 and do what with it? Multiply it by 1/3. What do we need to do with row 1? Multiply it by 1/2. So we have 1, 3, 8, and 0, 1, 3. Very minimum, you need to get to here. Now, how much work would it be for us to get it into reduced row echelon form? One more step. What would that one more step be? We could solve for x and y from here, but if we wanted reduced row echelon form, the 1, 0, 0, 1, what would our one step be to get this to be a 0? Multiply that bottom one by what? Okay, we can take negative 3 times row 2 and add it to row 1 to get 1, 0, negative 1, 0, 1, 3. And without any algebra, we know that our coordinate of intersection is negative 1, 3. Pretty sweet, right? Okay, now, at the very least, you need to get to here. So you can say y equals 3, x plus 3y equals 8. But in my opinion, if you're doing a 2-variable system, if you're going to have to do the one step for the algebra here, you might as well do the one step to get it into reduced row echelon form. Okay? Saves you some algebra. Okay? So these 2-variable system ones, they shouldn't take you very many steps. Okay? It should take you about 2 or 3 steps to get it into row echelon form. Maybe 4 steps. Okay? Now your 3-variable systems, those are going to take you a few more steps depending on the problem. You're going to have to be patient. Okay? A lot of this is going to be practicing. All right? And the more you do, the more vision you are going to have as to what will work and what will not. What will actually be a hindrance in your problem or what will actually be helpful in your problem. Okay? So I'm going to show you how to do these in your calculator, but then I'd like to give you some time in class to do a couple before you leave. That way you can kind of do some on your own with your peers before you go home to do it tonight. Okay? But go ahead and get out your calculator. Okay. So the first thing is I need to show you is that we have a matrix menu. So if you go to math, nope, don't go to math. Do you see where the math button is? Do you see right below it the x to the negative first button? What does it say in yellow? Matrix. So if you hit second and then the x to the negative 1, this is our matrix menu. And there's 3 different options. There's the names, there's the math, and there's the edit. Okay? Now, we need to put a matrix in to our matrix menu. Okay? So, when you want to actually plug in the numbers, you need to go to edit. Now, it does not matter which one of these you choose. A is going to be the easiest. So I would just change A with every new problem you have. Don't choose A and then for number 2 choose B and then for number 3 choose C. Just change A every time. Okay? It's easiest to call up. So if you hit enter, it's going to ask you the order of the matrix. Okay? If we're going to solve this 3-variable system, what order are we going to put in? 3 by 4, there are 3 rows and 4 columns. Okay. So then what you're going to do is row by row, you're going to enter in these numbers. Okay. Your calculators are wonderful. The longest process is going to be typing in all of these numbers.
That's a long word. To click enter, like, why can't you just...
So arrow and enter, it's still just like a push of the button.
I know, but it's just...
Okay. Once you have your matrix entered, you need to hit second quit to go back to your calculating menu. Okay? Right? Where you can type in 3 plus 4 and it'll tell you that it's 7. Okay? That's where you need to be. Okay? Alright. So back to here. So we have exited the menu. Now, if you go back to the matrix menu, second matrix, under math, these are all of the commands that we can do. Now, you don't know what DET or augment or any of that means, but if you arrow down, A and B are REF and RREF. What do you think REF stands for?
Reduced echelon row.
Row echelon form. So let me show you. If you hit row echelon form, and then if you go back to your menu and under names, call up A, because that is the matrix that you enter numbers into. It'll give you row echelon form. Oh, Caleb says, if we can use our calculator, why wouldn't we do reduced row echelon form? Right? Now, first of all, let me show you this. Do you see how I have a decimal in there and I can't see the rest of it? Right? You know that you can hit math, fraction, and it'll change them all to fractions so you can see them. Yes. If you go to your matrix menu, under names, you just hit enter on A. Okay. All right, now back to Caleb's comment. But Mrs. Holman, we have a calculator. Why wouldn't we do reduced row echelon form? If you're using your calculator, reduced row echelon form is really the only button you would ever want to use. Okay? I'm going to get there. So if we go to our matrix menu, and instead, under math, if we choose RREF and call up matrix A, XYZ is 5, -1, -2. Does that make you happy?
Why are we even learning how to do
And then go back in.
that?
And then under
I feel like that would really help me organize my house.
Isn't that so fun? Okay, now back to Caleb's other question. Do we need to use calculators on our test? Your quiz and test will be both calculator and non-calculator, much like chapter 3. So I do need you to be able to do this by hand, but I also want you to be able to use your calculator. So on things like, I don't know, the ACT, if you wanted to use this, you could. Okay.
You should have made it.
Okay, now, you all are pretty happy about your calculators, and that's wonderful, but I need you to practice by hand.